In this part, these items will be explained. How colors change when it becomes lighter or darker. Brightness changes as you expect, saturation and hue will also change, but not the way you expected. I will also explain color temperature, which is very important in color theory. We will also study saturation and hue in image when the images become lighter or darker. How colors change when it becomes lighter or darker. It is meaningless to study color without light because without light you can't see anything. To make it simple to understand, I start with green color. Later we will study other colors. Light source dictates its color to the color of the object that is lit by the light source. Here I explain green in the natural environment whose main light source is sun and sky. Light source like sun or any other light source is like a dictator. It dictates its color to the color of the object. If a color becomes lighter or darker, its brightness changes as you expect. For example, look at this. If I move in this direction, the brightness change. This is what everybody expects to happen, and this is what we learn when we are children at school. But saturation and hue will also change, but not the way you expected. Wow, what does it mean? Okay, let's talk about it. How saturation and hue will change. How saturation changes when it becomes lighter or darker. Look at this example. It's an image of a hill. When I take color samples, not only the brightness changed, but also hue and saturation have changed. Look at this another example. When I pick color samples, not only the brightness of the color is changing, but also the hue and saturation of these green colors are changing. Brightness, saturation, and hue in the dark area is different from brightness, saturation, and hue of the light area. It's a common mistake that people think when a color becomes brighter, only its brightness change. But as I showed you in two examples, not only the brightness change, but also hue and saturation change. The question is how saturation and hue change when a color becomes lighter. When I move in this direction, or when I take color samples in this direction, only brightness of a color changes. As I showed you in two examples, it's a common mistake. What is happening in reality is that brightness, saturation, and hue change. If I move in this direction, the brightness change. And if I move in this direction, the saturation change. Here you see I have no saturation. But in reality, I have to move in this way. And also hue. In our hill and grass example, when warm light of the sun hit the surface of the hill or grass, the green gradually shift toward yellow. The hue moves from green to yellow. Hue changes based on the color temperature. We will talk about color temperature very soon, but for now let's return back how brightness and saturation change. When the color becomes lighter, it becomes less saturated. Imagine light as a washing liquid that washes saturation and brightness. To remember, look at this example. When I pick color from the darker and lighter green, when it becomes lighter, it moves in diagonal direction. So at the same time, brightness and saturation change. It becomes less saturated as we talked about it. It's another very obvious example. If you take sample from the very hot area to the area around the fire, as it's become darker, the saturation increase. It comes from almost no saturation to very saturated. We talk about the saturation when it becomes lighter. Now we will talk about saturation when it becomes darker. If a color becomes darker, it becomes more saturated. If you don't follow this rule, your painting will look muddy in the dark area. Look at this example. The warm light of the sun hit this green sphere. It becomes brighter and less saturated, and hue shifts from green to yellow. The shadow area is lit by the blue sky. It is lit by the indirect light of the sky. It is not a direct light from the sun. In the shadow area, we have blue because the sky is blue. So we have a cold shadow. What is cold and warm shadow? We will talk about it very soon here. But for now, just know that this shadow, it's a cool shadow because the blue light that comes from the sky. In the shadow area, we have two areas. One area is a bigger part and the other area is the smaller one. The smaller one is called contact shadow. In this area, because the two objects are very close to each other, it's more darker than the other part. It's very close to the object. This area is called contact shadow area, and it must have a warmer color because it's not as affected by this area by the sky. This part is very cold because it's very affected by the sky, but this area is not. Okay, so let's return to our point. If a color becomes darker, it becomes more saturated. Here, if I pick a sample from this area, the saturation is around 25 or 30. If I take a sample from this area, it's around 9. So the saturation here is much more. Don't do this. It's look unbelievable and it's look muddy in the dark area. So if a color becomes darker, it becomes more saturated. This is the right way to do it. And this is what is happening in the nature. Let's look at this example and see how saturation change in the dark area. If I pick color from the darker area, you will notice that saturation is more than the bright area. Again, here, if I pick sample in a darker area, is more saturated than the lighter area. Here I come from light area to the dark area, and as you can see, saturation increased gradually. Here it's more easy to notice. In the light area, the saturation is around 20, but in the dark area, it's almost 90. Again, in the lighter area, we have less saturation. In the dark area, we have more saturation. So keep in mind, when color becomes darker, it becomes more saturated.